Given that x equals 3 is a 0, find all zeros and graph the function f of x equals x cubed minus 5x squared plus 3x plus 9. To begin with, because I know we're going to have to graph this, I want to examine for a few characteristics, one of which is end behavior. So because we have an x cubed is our leading term, that means it has a positive leading coefficient of 1 and an odd degree of 3. So the end behavior is that this graph will be falling to the left, rising to the right. Just want to hold on to that. In addition, we can find the y-intercept fairly easily. If we evaluate for x equals 0, that would be f of 0 equals 0 cubed minus 5 times 0 squared plus 3 times 0 plus 9, which would give us a y-intercept of the point 0, 9. And on my graph, I'll go ahead and put that information. So 0, 9 is a point. And it is falling to the left. I'm going to draw an arrow going down to the left in the third quadrant, and rising to the right. I'm going to draw an arrow going up and to the right in the first quadrant. Now let's take that 0, x equals 3, and we're going to do synthetic division. Take our coefficients of 1x cubed minus 5x squared plus 3x plus 9. Our synthetic division will bring down the 1 first, that leading coefficient, so 1. And we're going to multiply by the 0 we have, x equals 3. So 3 times 1 is 3. And add that to the negative 5 that I have, so negative 5 plus 3 is negative 2. Multiply by 3 again, 3 times negative 2 is negative 6. And then we'll add that to 3, so 3 minus 6 is negative 3. Multiply by 3 again, multiply by negative 3 is negative 9, and then 9 minus 9 is 0. So this function, f of x, factors as parentheses x minus 3, close parentheses, open parentheses, x squared minus 2x minus 3, close parentheses, based off of the values we just got from our synthetic division, the quotient of that is. Now, x squared minus 2x minus 3 factors as well into parentheses x minus 3, close parentheses, open parentheses, x plus 1, close parentheses. So that f of x is now equal to parentheses x minus 3, close parentheses, open parentheses, x minus 3, close parentheses, open parentheses, x plus 1, close parentheses. Now, this means there are two zeros. We have a 0 of x equals positive 3 and a value of negative 1 with corresponding multiplicities of 2 and 1 respectively, because x minus 3 factor occurs twice, the x plus 1 factor occurs only once. Now we know that when the multiplicity is even, such as multiplicity equal to 2, it's even, that will touch. Touch and turn around is usually how we write that, or how we say it. And a multiplicity of an odd value, in this case 1, will cross. So on my graph, I already have my y-intercept and my end behavior. I'm going to also plot these two x-intercepts. This means x-intercept at negative 1, 0, and an x-intercept at 3, 0. Now we can connect the information all together. So I'm going to start from my third quadrant, part where I have it falling to the left, and I'm going to rise up to negative 1. Go back to that, actually should connect. All right, so it's going to rise from the left up to the point negative 1, 0. I'm going to have to cross through that point based on my multiplicities up to my y-intercept of 0, 9, and then it'll have to decrease to fall going from there, from the y-intercept, over to our next x-intercept of 3, 0, and then to make the end behavior match, it will have to increase going that way. Now, my graph is very jagged. Polynomials are smooth, so this is not a very good sketch. I'd probably want to go back, erase some things, and smooth it out. But this does have all the right characteristics. So if we use some other tool to graphing utility to see what this graph would look like, it would look similar to this, but it would likely be, like I say, much, much smoother.